This video, I'm going to show what I would suggest a new user does to make some test cuts in different materials. This was a job file that a customer had sent me to have me look over and kind of evaluate how he was doing things and what looked good and make sure his feeds and speeds are right. So the first thing I always do is look at the material setup here. So this was a 3/8 inch thick acrylic full-size panel. Sizes are a little weird, but I'm guessing he's doing that because he's got some offsets here. So he's drawing his parts against the corner of the piece. I don't do that. I draw them, and I'll show you what I would do. This has already been modified. I'm not using his file name. So I would do it and place these parts where they're going to be on the sheet. I have spoken with him, and what he was doing was, if he marks his sheet here, it's going to move all the vectors that are on the sheet over 1/4 of an inch to the right and up, so that he has room to hold down, or he's coming off the factory edge. So I draw them that way instead. So I would put a 48/96 if that's my material size. I put my true size and not use this offset on the XY00. So then with the laser light, I peg it on the corner of the material, and I would have these parts shifted up an inch or so, however I'm holding it down. I don't know. I may be pre-drilling this into the spoil board. He may be using tape, CA glue. I'm not sure what his method's going to be, but I would turn this off personally. So we'll let that go though and tell it okay. It's warning that the setup is going to cut through the material, and it's only going 0.385. So he's only going 10 thousandths of an inch into the spoil board. I typically go 20 thousandths, 30 thousandths. I use the spoil board as a spoil board. I cut through it on purpose and just replace it. I use paneling. I do not use 3/4 inch material for the spoil board. The table on the SmartBench is a little different in that it only supports the spoil board where the X beam is and in the middle of the table. So in my shop in Birmingham, if I leave a piece of 3/4 MDF up on the spoil board over the weekend, it's going to droop on the corners here. And then when the X beam goes to it to bring everything perpendicular to spindle, it will raise that up. But it'll also, because it's 3/4 of an inch, it will hump up off of the table in the center of it. So don't use a thick spoil board. There's nothing that says to use a thick spoil board. Everything says use a thin spoil board. On the Yeti, my movies at Yeti Tool Southeast, or any of the movies that are done through the Yeti CNC Academy. So that all looks good. He's got the tools turned on here. So let's just look at what he did. So we're going to hit the curtains and go from the design side to the cut listing side, and we'll look at the profiles that he's using. Again, he's specifying only 10 thousandths of an inch deep. That's fine though. 3 passes, so 1/8 of an inch per pass roughly. He's cutting on the outside. I would do a separate last pass. I'm not sure how this acrylic is going to be used, whether it's going to have an edge to it or an exposed edge or not. But I typically would turn on and do a separate last pass at 20 thousandths. And I don't know how he's holding it down, so I would typically add tabs or have some hold down method. And again, if we're drilling these circles here first, we could, depending on how we're doing our runners for the upper beam, we could screw down through these holes. But I would do ramps. He's got a ramp coming in, and it's set at 2 inches. That's going to be slow if we look at our speeds. So everything basically looks okay here. He's ramping in. It's a longer ramp than you need, but let's look at the speeds. So we're going to go to the tooling that he selected. It's a 1/4 inch end mill, and we're going to edit the setup, and we're running 19,000 RPMs. That's good, but the feed rate is awful slow. 600 millimeters per minute is not going to give us the speed that we want. The swarf, the debris, is not going to be adequate to cool the bit, so that we need to jack up. And also the plunge rate is only 10 inches per minute. I would double that, so I'd easily go 500 for the plunge rate, and that's 20 inches per minute roughly. I mean, I'm not going to do the metric equivalents, and I do everything in imperial numbers on my setups. But the feed rate, I would go at least, I'd program it the first time for the test cuts at 100 inches per minute. And depending on how I'm doing the cuts, whether I'm doing small ones or larger ones, test it. But that's what you want to do. And he's cutting a new material because he's a new SmartBench user. So I wouldn't start on a finished product that he's due to deliver to a customer. So I would basically make those changes. I would also, with acrylics, I would change to do lead in and lead outs. You could do a circular with the length lead being 2 inches or whatever, so that we're getting full depth before it gets into the material. That's fine. And then I would have it, I'm going to call this profile EJS because I've got different speeds. Test. No vector selected, of course. That was silly. So I would do, and I do my holes separate from my profiles there. So I would calculate those, tell it OK, and I'm going to go back to do it the way I would do it. Now that they're selected, I'm going to use the arrow keys and move them up and over. I still have room to, if I turn off my tooling, I have room to hold this down on, they should have been grouped, so I'm going to do Control Z, edit, undo, nudge, Control Z multiple times. I'm going to select everything. I want the holes to move appropriately with the 2 rectangles. So now it's moved. And then when I do this work again, I can just double click on this again, and it's going to reselect it, recalculate it, and we're good to go on the panel the way I would do it, with everything separated from the edge of the file. So regarding the ramp in, ramp out, let's look at the lead in, lead out. I like to do circular ones. The way I had it clicked was doing a straight lead in. I just prefer these. I can see them easier, and we're going to recalculate. I do it lead in and lead out. What that can do is stop the bit from moving up and down once it finishes the cut in the cut line. If it moves up and down and the bit is hot, it can burn wood or other materials like that, or it can melt the acrylics. So by doing this, we're going to basically come in from here, ramp down to get to the proper cutting depth before we get to our vector line, and the edge of the tool should be on the outside of the vector, and then make the first cut and then come out. Come back over here, do it again for the second cut, and come out. So that will work really well. If we look at how that's determined, I can turn on the 2D view by just clicking over here. That's where we can look at this information, or I can split the screen. So I'm going to zoom in here, and if I turn off the tool pathing, but go to the vector that I was working with and hit the right button and go to node mode, the green box is the start of that mode, the way the rectangle in this case was drawn. I can change that and put it anywhere. I can just hit the right button and say insert a point. Now that I have a point, I can hit the right button and say make that the start point, and then now it would ramp in here, and we'll let it calculate that. And so now it's coming in that area. You can also do that from within the lead in, lead out area. If I go to leads, I can say start at, and I can have it selected, or I can say I want it to be on the middle of the bottom side. So I'm going to slide down, move it to the middle of that. So there's all kinds of power in this. Let it recalculate, and now it's here and does it there. I didn't want it up here, because if I did it up here, it would be in the middle of the other piece. And that's what it said here. It gave us a warning because it did it for both of these 2 rectangles. And if we look right here, we can't fit that, shifting it, we can't fit the specified lead in and lead out there. So on that one, I would have to change it. Again, I'll just make it easier. I'll turn off node mode, or turn off the tool lines, go into node mode, and specify to insert a point and make that the start point. And then, although I have told it to do it and specified it there, it's going to redo it based on having that as the start point. No, it doesn't. So it doesn't. The problem with doing it that way, by specifying the start at points, is it's going to do it for each of the 2 shapes that I have, and they're not close enough. So if I do them on this right edge here, then that's fine, and it will work. If not, I got a pop-up message saying it had to clip some of that circular lead in order to make it not interfere with the adjacent part. So we have to watch those if we're going to use the global type tool. I don't typically do that. I just select my points and put them where I want. But that works well if that's the way you want to think. So with that said, this is a better setup for it, but I would definitely make sure that you're checking your feeds and speeds. With acrylics, speed is your friend. Going slow is your enemy. So let's adjust feeds and speeds, get them up at least 100 inches per minute, probably 150, but let's try it. So how do we try it? Before I cut this part for my customer, I would go ahead of it and draw some small rectangles and do some test cuts. So here's what I would do. I would put a 4 by 4 inch rectangle. You can do the softer corners, radius corners or not, doesn't matter. But I would do one of these, and I'm going to select it, use my arrow keys, and drop it down here into some of the waste. And I would do the same exact setup. Now, if I wanted to really test the full speed, I could do it more like a rectangle, and to give it time to get up to speed. So I'll make the height, say, 12 inches. Because it's going to ramp in, again, if we look at these setups, it's going to ramp in slow in this circular part, then get to speed. But it takes time to get to top speed, to go from ramp speed, which was, we changed 20 inches per minute roughly, to high speed, 100 inches, or whatever we're going to use. So I would set this up this way. I'd go to node mode right away, and I'm going to have it make this the start. Well, this is the starting point. That's fine. So it'll get to speed and get closer to being at full speed before it has to slow down and make the turns. So what I would do is you may do a couple of these and do Control C to copy, Control V to paste using a Windows system, and drag it over and have multiples of these. And I would do the same thing with the holes too, because they're different. So I'm doing Control C, Control V, and so if I select them, I can nudge them down to get them out of the way, and go back to the tool pathing. And then so what I would do is I'd set up, and I'd come into it. I don't want to use the one that I was using before. I'm going to deselect everything, turn off the tool pathing on screen, and I would do a profile cut, and I would pick the same information. I would do this in 3 passes. And again, I could be more aggressive on this, but we can test it. We're going to be outside. I would do a separate last pass, so I'd oversize it by 20 thousandths or so. So what it's going to do is take the edge of the tool, rather than being against the finished vector, it's going to oversize it by 20 thousandths for the first pass and the second pass. Then the third pass, it's going to bring it back so the edge of the tool is at the vector line on the outside of it, and do the third pass. Now that's going to take the witness lines out of the first and second pass, if there are any, depending on the material. This may be important on this material, it may not be, depending on how it's being used. I would add tabs, and I'm just going to do these manually, and I would just make them 3D tabs, and I'll just add them on there. No vector selected. I would do this one and edit the tabs, and I just put one here and one here. If I want to move one, I hold down the left button and drag it. If I want to delete one, click the left button when it's in tab mode. I'll just leave it like that. He may be using tape, I'm not sure. And so I do want to do a ramp in, and I would do a lead in and lead out. Turn it on. I'd like the circular ones personally. That way I'm doing the full depth of cut before I get into the material. I want to be out of the cut line as much as I can. And I will let it select the order, and I will move it if I need to. I don't need to select it here. It's going to do it there because it's turned on, but I can also have it keep my current start points, but let it go. So this will be profile, test cuts. And so with this, I know I'm running 100 inches per minute. I know my plunge rate is 50 inches per minute. I know I'm doing a climb cut. I know that I'm doing an allowance, an oversized allowance. I know I'm doing tabs, and I know I'm doing the circular in and out. So let that go, and there's my setup. So comes in slow, gets to the full depth of cut for the first pass, and takes off. Makes the turn, and I have 12 inches roughly for it to work here before it makes the turn. That's 10 inches before the turn probably. So it can get up to a fairly good speed. See how I like that? Cut that piece out and mark it. I would put that information. I'd put my feeds and speeds, my rotation, that I did a finished pass allowance, that I did a circular ramp in, ramp out. Once I get this dialed into to the way I want the finished product to look, then I apply that to the rest of the material that I'm going to cut for the customer. Of course, we know that we can also, this test cut, I can raise that up and do that first. And so that's all I'm going to cut out of this sheet. The sheet's on the table, ready to cut for product for my customer, his customer, but I'll do the test cut first. And I'll do the same thing with the holes. I'll come back in here. The way he had it set up, he did the same setup, and it works. He had the same setup for the parameters for the border cut, and was using that same information to be on the inside of these lines, of these holes for the inside cut. I typically do my holes separate because I may play with it. I may do a longer ramp in, ramp out, so that I'm doing a helical setup. But I'll change the speed as fast as I can, but it's going to do a helical setup just to dust the whole thing and cut all the debris away. So that would work too. So I would do a profile cut. Turn off everything you see. I'll do a profile cut. Keep the same information, but I'm going to speed up the ramp in, and I'm going to put it at our max is like 43, so say 40 times 25.4, so 1,000. If I'm in millimeters, I'll do 1,000. That's the fastest we can basically go in our down spiral, because I'm going to set these up to do a longer lead in. I'm going to ramp in over 2 inches. So what it's going to do, or say 3 inches. So what it's going to do is just go in and go in a circular while driving down and cutting. And we'll let it profile, test, cut, circles. And it's warning us it's going to cut through the material. Again, that's not deep enough. I'm going to change that to deeper. And I'm going to do T for the thickness of the material plus 0.030 equal. So I'm going 30 thousandths deeper. And I'll do that in 3 passes. And calculate. More just is going to cut through the material. And then I'm going to zoom in. We're going to look at this. It's going to go so fast we're really not going to have time to see it probably, but you can see there. Whoop. You can see there the multiple passes. It's this, but you can see here the setup that it's doing, just a spiral entry all the way through. So we'll reset that preview, and I'll slow it all the way down and preview the visible. So there it is. It's just going down. Now we want to make sure too that when we did this, that we're on the correct side of that line. So I'm going to close this down, and I'll turn on the toolpath, and we want to look at them here, and we're on the wrong side of that line. So I did this by turning this off and on, and it can be a couple different ways. It can look like this, where it shows the direction of the travel and also the center line of the tool, but I like to use the blue lines because it's quicker sometimes. And I see that I'm cutting on the outside of that tool, so that's wrong. So I'm going to go back into that operation, and I'm going to change it to the inside of the tool, and that made sense. I just missed it. And we'll recalculate, reset. So if after you've done this, you don't like the quality of this first set of holes, and what I would do is now raise this up, and those would be the first 2 that I would send to the machine. If I don't like the quality of the edge of this part and the holes, or I can put the holes inside, it doesn't matter, I can modify it. Do it again. Take that whole thing, take some of these holes, and I'll do Control C, Control V, copy and paste, and I'll just drop them into the into the part. So then I can see, and again, I can write all this information on this sample part and keep this on a keychain or something on the wall. So I have my feeds and speeds for 3/8 inch thick acrylic with a certain bit. So I'm using a, say I'm using a 1/4 inch spiral O, and I know my feeds, my speeds, my ramp in, my ramp outs, finished part adjustment. Write all that on that piece and keep that piece so you're ready to refer to it. Now, one other thing you can do, you can save this job as okay, so I'm going to put these under Vectric, and I'm going to create this a new, and I'll call this master list. So this folder is going to be called master list, and I can call this in acrylic 3/8 inch. Now if I do this, it won't let me take the quote sign. So again, we're going to go back to old school. 0.375. And then if I go to edit notes and put a period as my first entry, this will pop up when I open this. So I'm going to have a folder called master list where I can put my different materials in there, whether it's coroplast, dye bond, HDU, acrylics, whatever. And this will be, my favorite tool would be a spiral O, and that's a 0.25 inch tool, and I did 100 inch per minute, 50 plunge, 0.020 finished cut allowance, ramp in, spiral, lead in and out, and this was a climb cut with tabs or without, you know, it doesn't matter. That's so that's my information. So I can pull this up and I can have a nice quick reference. So if we close this down, so I'm going to say file save, and then I'll close it. I'll just open a new one. So I open this up. I closed that out and didn't show it. I don't want to have anything that shows file names and things like that. So this is the master list. And then there's a file called acrylic. We open that up, and then this pop-up box will show up. So there's my information. Now I use this notes all the time if I want to change a design a little bit or tweak the design, and I'm going through different iterations of the design. I use this edit notes, put the period in there, and it pops up every time someone opens the job. So that's pretty cool. So I'm going to end this video there. I'm Eric Schiller with YetiSmartBench.com. I sell and support the Yeti SmartBench in the U.S. I've got machines in Canada and the Cayman Islands all over. So if I can help you in any way, give me a call. I introduced the machine in 2019, and I've got extensive experience with it and CNC in general. I look forward to working with you. Thanks for watching.